In note 6.6, example 7, we're going to use right triangles like we did back at the beginning of chapter 6 to evaluate composition of inverse functions. So when we're going to use right triangles, we're going to use SOHCAHTOA, right triangle trig. So in example 7a, we're asked to find the cosine of sine inverse of 5/13. And in order to solve this problem, we have to recognize that sine inverse of 5/13 is an angle, right? We have to realize the meaning of the output from inverse sine. So this is going to be an angle in the interval from negative pi over 2 to pi over 2, whose sine is 5/13. So going back to our right triangle trig, we can draw a right triangle. If it's an angle between negative pi over 2 and pi over 2, it's going to be either in, I'm going to draw the triangle either in quadrant 1 or quadrant 4. Since the sine is positive, the y value is positive, I'm going to draw the triangle in quadrant 1, and I'm going to put theta as the reference angle, going back to the horizontal axis. Sine is the length of the opposite side over the length of the hypotenuse. So sine inverse of 5/13 means that the length of the opposite side is 5, the length of the hypotenuse is 13, and now we need to find the missing side. We could call that x. If you recognize that this is a 5, 12, 13 triple, then you automatically know that x is 12, the missing side. If you don't recognize it as a triple, you can say x squared plus 5 squared is equal to 13 squared, and then you can solve the Pythagorean theorem. So we would have x squared plus 25 equals 169. X squared is equal to 169 minus 25, which is 144. And then we can take the square root, so x is equal to 12. Okay, now we've set up our triangle, which represents the angle given by sine inverse of 5/13. And now we just need to find the cosine of this angle. So if we want the cosine of sine inverse 5/13, we can just look at our triangle that we drew, remembering that cosine is the length of the adjacent side over the length of the hypotenuse. So for our triangle, the adjacent side is 12 and the hypotenuse is 13. So this answer is 12/13. For the next problem, we have sine of cotangent inverse of 4/3. I prefer to work with tangent inverse, so we can do tangent inverse of 3/4. You can work with cotangent if you want. So tangent inverse of 3/4 is an angle in the interval negative pi over 2 to pi over 2, excluding the endpoints, whose tangent is 4/3. And remember, tangent is opposite over adjacent. So I'm going to draw a triangle. It's either going to be in quadrant 1 or quadrant 4. Since tangent is positive, that means it has to be in quadrant 1, because in quadrant 4 tangent is negative. So I'm going to draw my right triangle in the first quadrant. The length of the opposite side is 3. The length of the adjacent side is 4. And now we need to find the missing side. I'll call it C. So either you can recognize that this is a 3, 4, 5 triple. So I know that C equals 5. Or you can solve Pythagorean theorem. So C squared equals 3 squared plus 4 squared. So C squared is going to be 9 plus 16. C squared is 25. Take the square root of both sides, and C is 5. So either way is fine. Now once we set up our right triangle, now we need to find the sine of the angle that's represented in our little right triangle. So we want to find the sine of cotangent inverse of 4/3. And sine is the length of the opposite side over the length of the hypotenuse. In this case, the opposite side is 3. The hypotenuse is 5. So this answer is 3/5. Okay, in the next example, we're asked to find the secant of cosine inverse of 8/17. So I have a note here that a right triangle is really not necessary because secant and cosine are reciprocal functions. So I could really just rewrite this as the secant inverse of 17/8. And now these functions will undo each other. So I know the answer is 17/8. But let's say that we want to just go through the steps. So we'd start at the inside, like we always do for inverse trig functions, and work our way out. So cosine inverse, this is going to be an angle on the top half of the unit circle, so between 0 and pi, whose cosine is 8/17. And remember, cosine is the length of the adjacent side over the length of the hypotenuse. So I'm going to draw a little right triangle. The top half of the unit circle is either in quadrant 1 or 2. Since cosine is positive, we need to be in quadrant 1. If cosine were negative, we would draw the right triangle in quadrant 2. And the angle is always the reference angle, never going to the y-axis, but always to the x-axis. So the length of the adjacent side in our little right triangle is going to be 8. The length of the hypotenuse is 17. And now we need to find the third side. Let's call it y. Either you can recognize that this is an 8, 15, 17 triple. So y is 15. Or if you use Pythagorean theorem, you can say 17 squared is 8 squared plus y squared. And then you can solve that for y. You will also get that y is 15. Okay, so now we're up to our last step. So we need to find the secant of cosine inverse of 8/17. Cosine inverse is the angle represented by this little right triangle. So now we need secant from the little right triangle that we did. And secant is hypotenuse over adjacent. So the length of the hypotenuse here is 17. The length of the adjacent is 8. So this answer is 17/8, which is what we got initially. All right, last problem. Now we're asked to find the sine of cosine inverse of a v. And we need to write this as an algebraic expression. So remember, cosine inverse of v is going to be an angle in the interval 0 to pi, so on the top half of the unit circle, whose cosine is v, and I'm going to write it as v over 1 because I'm going to think of cosine as a ratio of the length of the adjacent side over the length of the hypotenuse. So I'm going to make a little right triangle, and I'm going to assume that v is positive for this. Okay, so I'm going to assume v is positive, so that cosine is positive, so that'll be in the first quadrant. So the length of the adjacent side is v, the length of the hypotenuse is 1, and now we need to find the length of the missing side, which I'll call x. So by Pythagorean theorem, I know that v squared plus x squared is equal to 1 squared. So x squared is going to be 1 minus v squared, and then I'm going to take the square root. So x is going to be plus or minus the square root of 1 minus v squared. But since I'm in the first quadrant, I'm going to take the positive square root. Okay, so in Q1, this x is positive. So I need to just say x is the square root of 1 minus v squared. So that goes here, the square root of 1 minus v squared. And I'll put the little angle theta in. So now that we have the right triangle set up, we simply need to find the sine of the relationship from the right triangle that we set up. So that's going to be the length of the opposite side over the length of the hypotenuse. So the length of the opposite side is the square root of 1 minus v squared, and the hypotenuse is 1, so it's just the square root of 1 minus v squared.